Configuring WebSockets in a Spring application is relatively straightforward thanks to Spring comprehensive WebSocket support and the Spring messaging module. However, the complexity can vary depending on the specific requirements and features you need. For basic WebSocket configuration, you can get a simple setup running with relatively little effort. That's what we will focus on today. So without further ado, let's begin. First, to be able to use WebSocket in Spring applications, you must add Spring Boot Starter WebSocket dependency to your project. For Maven build tool, you add it by modifying pom.xml file with new dependency tag. For Gradle project, you just add it by implementing in dependency sections in your gradle.build file. Let's start with general configuration of WebSockets and break it down. Create new bean with add configuration annotation. The add configuration annotation in Spring is used to indicate that the class declares one or more add beans methods and might be processed by the Spring container to generate bean definitions and service requests at runtime. The add enable WebSocket message broker annotation is a part of the Spring framework, and it's used to enable WebSocket message handling backed by a message broker. It enables the use of WebSocket to facilitate real-time full duplex communication between the client and server. It provides configuration options to set up a message broker for processing messages sent by clients. Message brokers handle routing messages to the appropriate receivers. It typically works with the STOMP, Simple Text-Oriented Messaging Protocol, to handle the messaging. This allows you to define endpoints and message handling rules more conveniently. The annotation abstracts much of the boilerplate configuration, allowing you to focus on defining your application-specific WebSocket behavior. When you use @enable WebSocket message broker, you need to implement the WebSocket message broker configurer interface in your configuration class. This interface provides several methods to configure message broker options and endpoints. Set up a message broker with the destination prefixes you specify. For example, /topic for publish subscribe messaging and /q for point-to-point messaging. Register STOMP endpoints that the client will connect to, enabling fallback options such as sock.js for browsers that don't support WebSockets. Now, to handle incoming messages and the communication in general, you need to provide controller. It indicates that the class is a web controller capable of handling HTTP requests and returning responses ideally suited for Spring Web MVC applications. In this case, we will handle the STOMP protocol, which stands for the Simple Text-Oriented Messaging Protocol. The add message mapping annotation is used to specify the message destination that the annotated method should handle. Methods annotated with add message mapping are expected to process incoming messages. The method can take message payloads and other parameters as a method arguments. If a method annotated with add message mapping returns a value, it can be sent to a specific destination using the add SendTo annotation. WebSocket communication is asynchronous. Springs take care of the managing the message lifecycle and delivery of the appropriate handler. When a method annotated with add message mapping returns a value, the add SendTo annotation can be used to direct the return value to a specific topic or queue. This allows you to broadcast messages to all subscribers of that destination. This annotation specifies that the return value of the send message method should be sent to all clients subscribed to the /topic public destination. The SIM message header accessor class provides a range of methods that make it easier to access and manipulate the headers of messaging within the Spring WebSocket. Let's get back to the @send annotation once again. There is another similar annotation called @SendToUser annotation. @send is general broadcasting of messages to the destination to which multiple clients might be subscribed, suitable for sending messages to a topic or queue where any number of clients might be listening. This is typically used in scenarios where you want multiple clients to receive the same message. @SendToUser, on the other hand, is for sending messages to a specific user's queue, suitable for private or personalized messaging scenarios where the message is intended for a specific user rather than broadcasting to all users. It directs messaging to a user-specific queue, usually referenced with a prefix such as /user. It is leveraging user session and authentication information to route messages correctly to the user private queue. Spring tracks the current user information through the session established during the WebSocket handshake. This information is used to route the message correctly. For example, at SendToUser queue private annotation will map to the /user/username/queue/private internally. Overall, basic WebSocket configuration in Spring application is not very hard and can be achieved with minimal setup. However, as you add more features and handle more complex use cases, the configuration and management can become more involved. Fortunately, Spring becomes a comprehensive and flexible framework that supports both simple and complex WebSocket scenarios. See you in the next one.